I would like to introduce Heis Warner. Heis is the Director of Marketing and Distribution for the FCI Basics Business Unit at Amphenol Communication Solutions and brings over 25 years of connector industry experience. Thank you, Heis, for joining us today. You now have the floor.
Okay, thanks, Greta, for this great introduction, and thanks everybody for joining this webinar, where we are going to talk about electrification, battery management systems, and a lot of subsystems, and obviously about the connector opportunity for those kind of applications. There's quite some information to be presented. I have quite some slides, so I will get through many of them. But as mentioned, I mean, you will get the presentation after the webinars for your reference, and there's more bonus information to it as well. So this webinar is brought to you by the FCI Basics Business Unit, as mentioned. That's one of the largest business units of Amphenol, specialized in PCB interconnect, as you can see from this slide, right? Wire to board, board to board, input output, and FPC connectors with some recognized brand names. I'm sure you're well familiar with, like Bergstack or Minitech, those kind of products, and the opportunities, of course, through our channel partners like yours, because the majority of our business goes through distribution. So let's have a look at electrification as such, right? I mean, we all know electrification is the process of replacing technologies that use fossil fuels, right, as depicted on this slide, and obviously with technologies that use electricity as a source of energy. So renewable energy is coming to play here. What is the relevance of this? Of course, it helps to reduce greenhouse gas emissions, right? So electricity generated, as we all know, from renewable sources produce no emissions, which help to mitigate climate change, etc. It improves the energy efficiency because electrical vehicles and appliances are much more efficient than their fossil fuel power counterparts. So less energy to be used in the same amount, doing the same amount of work. And obviously, electrical vehicle, you can also read like a forklift or anything that uses that is mobile, like e-mobility. And last but not least, I mean, electrification also helps to improve public health, right? Because if there's no emissions, there's less air pollution, and there's also quieter, right? So that's the obvious, advantage of it. I mean, some of the challenges, as we know, is can we build enough capacity, and can we have enough availability of renewable energy sources like solar or wind or other sources. We still need to improve the efficiency. If you talk about vehicles, you talk about range, of course. And first, also very important point is we need to upgrade the electric grid, because we need to plug in all those appliances. They need to be charged, etc. And there, of course, battery technology comes into play. And what's driving it, obviously, because of the advantages just mentioned, is at the one hand, we have the international and national sustainability ambitions. I mean, for example, in the European Union, obviously in the US, but also in China. So governments are driving initiatives into this area, right? And at the other end, I mean, I already mentioned it. I mean, the growth of the battery management systems is fueled by key developments. I mean, so electrification, you can read it as well, is driven by some key developments like subsidies, like the cost of batteries going down drastically, right? We see more and more electrical vehicles being sold and on the roads. Fuel costs are rising, fossil fuel costs are rising. Well, that's all contributing to the fact that there is more interest, there's more development going on into electrification. So if we look at the supply chain, I'm sorry for that, something happened there with a pre-recorded version. So we can distinguish between three energy storage systems, right? So those are systems which comprise the electrification supply chain. So we have commercial energy systems, residential, and we also have EV charging. So if you look at these commercial systems, these are these container types of applications, or containers basically you can find next to wind farms, solar farms, etc. And these are much more than just like a source for battery storage, right? They also are mentioned to monitor, to manage power. So much more than just like a battery pack. So there's a lot of electronics in there. There's a lot of PCB components. There's a lot of cables to be used. A lot of sensors to measure humidity, temperature, those kind of things, right? So it's not only a battery management system. It's an energy management systems. It's a power control systems. It's a whole set of systems which need to be very reliable because they operate in a environment where there's vibration, temperature changes, and they need to operate remotely very reliably. So if you look at the systems in there, we see typically battery packs being used, right, to storage the energy, and you see different being used for these batteries. So you see practices where flexible printed circuits is being used to connect the battery cells. You see systems where discrete wire is being used, either with a centralized module controller or decentralized module controller. And you can imagine if you go from left to right, the wiring complexity increases. What is driving these different design practices is the amount of space there is, but the component engineer, the system engineer, plays a very important role in this, because they have a certain preference, and they like to use certain kind of practices. And with that, I mean, obviously, if you connect cells, you need to control this, and you see that you have the need for a battery management systems. Either you see this being integrated, so really on this battery pack, or you see it being connected with a cable towards this. And this is the kind of building practice. If you talk about a battery and a battery management systems, you see in electrical vehicles, you see in warehouse robots, you see it in industrial cleaning robots, everything which requires a battery. You see this kind of packaging, so you will. And the battery management system as such, right? I mean, it's a kind of very important electronic component, yeah, which measures the battery state. So it acquires data. Of course, everything is about safety. Yeah, it ensures the optimal balance of the battery pack, those kind of things. So there's a lot of electronics in there. It's a very important component, and in electrical vehicles, it's becoming the brain of the car. You can imagine also for other applications which need to be, which use a battery. It has a lot of functionality for it, and it needs to be reliable. From a connector perspective, if we look at these battery management systems, right, and then especially from the connector point of view, yeah. So what you see is, in terms of interconnect requirements for these battery management systems, is that they need to be compact. Yeah, so they need to have high current density. They need to be lightweight. They need to being able to handle temperature extremes, so very high, very low. They need to be flexible. Often these system designers, these systems to be modular, so they come in different configurations. Yeah, obviously they need to be vibration resistance. And you might think, hey, even if a battery management system is in a kind of a container like the commercial energy system, then you still require some vibration resistance interconnect, just to be safe, right? So all these kind of requirements you see typically being requested for when people build battery management systems. And because of that, I mean, so this is for the battery management system. Industrial systems, even for warehouse robotics, the component engineers like to use these automotive grade connectors because they're proven, they're reliable, they offer functionality, for example, like ingress protection. So in other words, being waterproof. They have different latching styles to prevent unintentional cable release, etc., etc. So these are core components of these modules and battery management systems. On top, you see other kinds of PCB interconnect, like pin headers and mezzanine connectors. So it's always good to have a look at the circuit board because there's plenty of opportunity for these kind of applications. And this is a kind of an overview of, if you talk about battery management systems, these are the typical interconnects being used for battery management systems. So quite a lot of automotive grade interconnect, I would say, where we have developed Microspace is one of the leading products in this area. And the reason is because it offers the best current density in the market currently available. This offers a 4 amp current capability on a staggered footprint of 1.27 millimeter, which is unmatched. And we have expanded that over the past months, years with a waterproof version, recently with wire-to-wire, even with a high voltage version. And to accommodate other building practices, we also have FlexLock for FPC. So this is typically the stuff you find for battery management systems. And more information you will find in the pack we'll send out to you. If we look at the residential system, so that's around your house, so that's the third system, then you talk about basically your home energy management system, right? Which comprises a lot of, in the near future, a lot of different elements. We're all, I guess, familiar with our electricity meter, but if you have solar panels, you also have your inverter, you have your potentially your battery packs. You need to have a controller. So there's more and more functionality being added to homes as well, especially if you talk about energy measurement and energy management systems. Yeah? So the function really is to control, to measure, and to communicate. And typically in these kind of applications, you find a lot of PCB interconnect, right? This is a typical layout of an inverter where power communication signal board needs to be separated from the main board to allow for airflow. So you see a lot of board-to-board interconnect being used, and that's where the opportunity is, obviously, but also internal wiring systems, whether it's wire-to-wire or even hybrid wire-to-board. And of course, there's always an interface, right? There's always a little LCD screen where you either can see the status of the equipment or you can program, which of course requires FSC, FPC connectors, or etc. Right? So a lot of interconnect opportunity at inverters as well. And as you saw from that overview on the home energy management system, there's also all kinds of controllers. We're familiar with, I guess, in our houses. Whether it's the extended thermostat or the home automation system, right? Typically, it's a main board with some expansion boards, at least the communication board, memory towards it, and again, a user interface. So, even for these smaller controllers, you typically see up to 6 different types of interconnect opportunity in your area. And if we come to the EV charging station, so the third element, of the energy storage systems, the opportunity there is, for, of course, the what we call the EV supply equipment, so the charging pole, so you will, which again, requires a user interface. And if you look at, the car itself, obviously it has like a battery management system, etc. You see more and more opportunities for onboard charging, right? There's onboard charging is also a electronic unit. You can see it in a car. You see it in a electrical light vehicle, in a warehouse robot, in a forklift, etc. It's all electronics, right? And obviously, I mean, there's a lot of functionality here, right? Again, right? I mean, the charging pole looks like just like a pole to charge, right? But it really there is a lot of electronics in it because it's responsible for energy management and distribution. It monitors and controls. It meters, it bills, so it needs to communicate not only with the user but also with the provider. Those kind of things, right? That's all electronics. That all requires electronics and especially PCB interconnect. So if you look at it from a kind of a system build out, right? You see again here, typically for that charging pole, you have a main board again with a user interface. Where you can see status, where you can program. It has a processing unit because it needs to process quite a lot of information, and a communication board, right? It communicates with the provider, communicates with possibly an app or pure on your mobile phone, and you can see that all of these systems require a board-to-board wide board connector system. So typically mezzanine, pin on socket if there's space, yeah, and if you have a good visual on the mating half, that's still a very popular connectors to be used. And of course, there's also quite a lot of power electronics to it because these charging poles need to be powered by themselves as well to run all that all the electronics, right? And so not surprisingly, right, for these kind of applications, so again, quite a lot of PCB interconnect can be used. I already mentioned some of the mezzanine connectors. I'm pretty sure you're familiar with, like Bergstack family of products for board stacking. What's new, I mean, what we see as a development more and more is hybrid connected technology. On the lower left, you see combo stack as a new development in our portfolio. Why is that becoming popular? Because it solves some tolerance issues. If you have a power and a signal connector on one PCB, by nature you have a tolerance issue, and one connector can solve that. It saves space, right? And allows for safer mating as well. So becoming quite popular, and not only in board-to-board, but also in wide-board applications. And also modular systems, as we call it, right? And we have some established product lines like Quickie and Minitech and BV in the portfolio, which are still going strong, right? Because they're reliable, because they have good contact systems, dual beam contact systems. And whenever there's space on a PCB, component engineers like to use these, right? Because they have them in their product library. They provide reliable connections. Yes, they consume a little bit more space, but the component cost is also reliable. And upper right, we see Bergstack as a new development point forward. That's a very small connector, I would say, right? But it offers some robustness, not only in terms of operating a temperature capability up to 125 degrees Celsius, but also in terms of the design itself. It has ribs designed which can absorb vibration and stress. So typical examples of these products you will find in the package. And the essence is that all these products and the products I showed you before are all being developed for these kind of applications, which we would like to refer to as demanding applications, where specifications and performance matters, right? So these are not consumer grade, dirt cheap connectors. No, they're built to last because they can handle higher operating temperatures, multiple mating cycles. They are vibration resistant. They have dual beam contact system, and so on. So that's typically what component engineers like, because it's, I mean, relatively cheap components, but which you need to rely on, right? You want to prevent to have false meter readings in a commercial energy storage system, as an example, right? Because they're typically being placed remotely. That's what you want to avoid, and you can prevent that by choosing connector systems which are reliable and proven, as on this slide. Yeah, so I mean, if you look at these electrification, and if you look at battery management systems, for these types of applications, for successful designs. I showed you some building practices in battery management systems with flex, with wires. I mean, it's similar to inverters or controllers. You see quite a lot of different building practices around. Some is driven by, space requirements. Some is driven by the preference of the component engineer or the requirements for intermittibility, or it's driven by the history. Yeah, if people are familiar with certain interconnect types, for example, with Bergstack mezzanine connectors, which are being used quite a lot in IT datacom market, we see that being adopted in these kind of applications as well. So plenty of good connected technology to build on. Yeah, so in other words, whatever the building practice is, whether you talk about inverter, an onboard charger, a controller, and especially if you talk about all the different kinds of equipment, electrification is driving electrical vehicles, is driving material handling systems which operate autonomously, and which require battery. You see industrial and like cleaning robots more and more coming up. That all requires quite a lot of reliable interconnect, and that's something we have in portfolio. So that being said, I mean, this is like a kind of short introduction to electrification, some of the systems we see in this area. And I gave you like a sneak preview of some of the solutions we have for these applications. The details you will find in the package that will be sent out to you. And with that being said, I would like to thank you for your participation. And I guess, Greta, we can open it up for questions now.
Of course, yes. Thank you, Heis. Yeah, so if anyone has any questions, again, you can ask your questions on the Q&A button on the bottom of your screen. All right, so Heis, it looks like the first question is, the wire lock with the 1.8 millimeter pitch seems like a solution which consumes more board space compared to the 1.27 millimeter microspace. Why would a component engineer choose wire lock instead?
Yeah, that's a good question. And yes, it's true that this 1.8 millimeter connector consumes more board space, especially for lower positions versus the staggered version of microspace 127. However, I mean, 1.8 is a kind of a standard in automotive, which certain component engineers prefer. And also, if you go to multiple positions, so over 16, so in the 18-20 range, wire lock consumes less space than compared to microspace. So for high position numbers, it's sometimes preferred over microspace.
Great, thank you. And the next question we have here is, can FCI Basics also provide complete cable assemblies for these connector solutions?
Yeah, absolutely. I mean, it's a good question. So for all those wire-to-board interconnects, and even for flex printed circuit board assembly, so with board-to-board interconnect, we have a new facility opened this year in the first quarter in Mexicali to serve the Americas market. We have full capability to do all the cable assemblies for the connectors, which will be shown, which I showed in this presentation, and which you will find in the presentation, which will be sent afterwards.
Great, thank you. And it looks like we have enough time for one more question. Again, there is contact information in the chat if you do have any questions after the webinar time. So for our final question we have, for the FlexLock flexible solution, is this only meant for low-cost applications, or do main OEMs also use flexible solutions?
Yeah, so I assume you're referring to the flexible printed circuit solution for board-to-board. No, I mean this is not necessarily a low-cost solution. And you might be familiar with those FPC solutions, for example, in consumer applications like your mobile phone, right? It's especially meant to solve some design issues for connecting certain PCBs. It's meant to solve tolerance issues, because if you lose a flex, you don't have that rigid connection, obviously a more flexible connection to solve some tolerance issues. And sometimes it also serves PCB layout challenges, right? If you want to connect two boards, you don't have the space on the PCB, or the PCB needs to be placed on a certain angle. These flexible printed circuit solutions come in very handy. And mind you, these are really meant for basically all our board-to-board connectors. And typically how this is being done, I mean, you can solder any board-to-board connector on a flex. You use a stiffener for that, so it feels like a kind of a small printed circuit board with a flexible connection. So really reliable solutions we see also in very demanding applications like automotive or industrial applications.
Great, thank you so much, Gijs. And thank you everyone for joining us today and learning more about electrification.